Welcome again to your class. Today we're continuing with our interesting topic, which is on complex number. Okay, so today we're going to look at what we call Argand diagrams. Okay, so these are diagrams we draw for complex numbers. Okay, so we're going to learn about them, and you are going to be using them from now until the last lecture of this. Okay, so we're going to learn about plotting an Argand diagram. Okay, so I'm going to teach you how do we draw an Argand diagram. Okay, then the other thing is you're going to calculate the modulus of a complex number. Okay, so given a complex number in the form a plus bi, I'm going to show you how to calculate the modulus and how to plot the Argand diagram. Okay, so this is going to be our lecture on that. So please make sure you watch until the end so that you don't miss this important part. Okay, so remember we're going to be using it until the end of this complex number thing. So make sure you understood it. Okay, now it's time to press that subscribe button. Okay. Let's go to the Argand diagrams. Now let's answer this question. What is an Argand diagram? Okay, so it is a diagram which contains a complex plane. Okay, so we can say that it is a diagram to represent complex numbers. Okay, it represents complex numbers. Okay, so the first thing you want to do is you want to learn about the complex plane. Okay, so what we call the complex plane is it is a plane like x and y. I hope you understand about x and y axis. Okay, so it is a plane like this. Okay, so but the difference now is here we are going to write our Gantt diagram as it is going to become a plane like this. But the difference is this x-axis is going to become the real axis. Okay, so I'm going to be representing it with r. Okay, then and this y-axis is going to become the imaginary axis. Okay, so we're going to be representing it with I. Okay, so this is it. We're just going to plot our diagrams on a plane like this, which contains a y-axis, which is for imaginary numbers, and a real axis, which is for real numbers. Okay, so given our complex number, like a plus bi, what we are going to do is we are going to take this a and plot it on this diagram, on this x-axis, and we take this b and plot it on this axis, which is p. Okay, so now we are going to represent our complex number as a point here. Okay, so we're going to represent our complex number as a point here. Okay, so this is it on a Gantt diagram. It is a plane which represents the complex numbers as points. Okay, so a complex number is going to be represented as a point. Okay, like this. Okay, with an a here to the real part and an imaginary part, which is b here. Okay, so let's see how do we plot this. Our next part is going to be plotting a complex numbers on an Argand plane. Okay, so I told you that an Argand plane is a plane in such a way that it has an y-axis like this, which represent the imaginary numbers. Okay, so it goes this side and this side. Okay, then it has an x-axis like this, which represent real numbers. Okay, so this is our Argand plane. Okay, so we're going to learn how do we plot a complex number on this. Okay, so the first thing is you're going to learn, going to see which is our complex number. Okay, I'm going to use our complex number as 3 plus 2i as our example. Okay, so this is our example of a complex number. Okay, I'm going to explain how do we plot this one. Okay, so the first thing you have to do is you check out the real number, this real number. Okay, it's a positive 3, right? Okay, so you're going to move from 1 here to 3 here. Okay, so now what we're going to do is we're going to plot it from here. Now, from here. Now, we're going to see our imaginary part. Our imaginary part is positive again. We're going to see it's 1 here and 2 here. Okay, so you know that it is somewhere here. Okay, so what we're going to do is we're going to plot a point here. What we're going to do is we're going to plot a point here. Okay, so this is the point where it's 3 plus 2i. Okay, so this becomes our Gantt diagram of this complex number. Okay, so you can choose to draw a line here or from the origin to this one. Okay, so this is it. This becomes our complex number. Okay, so if it's a negative, like let me say it's a 4 minus 3i. Okay, what we're going to do is we're just going to draw here from 4. Here we have our 4. Then minus 3i is going to become minus 1, minus 2, minus 3, then minus 4 here, minus 3 here. okay, then you are going to go here, okay. So this one becomes our complex. So we're going to draw a point here, which is 4 minus 3i. Okay, so this is going to become our complex number. This is going to become our Gantt diagram. Okay, so make sure when you draw these lines which are straight and you label them well. Okay, so this is how we draw our complex numbers on an Gantt plane. Okay, so as easy as that, you have successfully drawn the first one. Okay, please try this one out and see if you can get it. Minus 3 plus 2i. Okay, uh, try this out. It's going to come this side. Make sure you understood it. Okay, so now let's go into the last part of this video. The last thing you're going to learn on this video is the modulus of a complex number. Okay, so let's understand what is the modulus of a complex number. Okay, so this is on an Argand diagram. The distance, it is the distance of a complex number point to the origin. Okay, so the distance from the origin to a complex number point. Okay, okay, so this is what we call the modulus of a complex number. Okay, so let's say we draw our Gantt diagram. Let's say it's 3 plus 5i. Okay, let's draw it here. I'm going to do it with this first. Okay, so it's going to become like this. This is the imaginary part, and this is the real part, and it's 3 here. 1, 2, 3, 3 here. Then 5 is 1, 2, 3, 4, 5 here. Okay, here's our point. This is 3 plus 5i. Okay, now what we're going to do is this distance from this to this, from the center, okay, a straight line here. This distance from the origin to this, okay, this is what we call the modulus. Okay, we can represent it as r. Okay, represent it as r. Okay, so this is the modulus. Okay, so how do we find this? Okay, so the modulus of a complex number, we can represent it as 3 plus 5i. Then put this. Okay, this is the modulus of a complex number. It's found by saying 3 squared plus 5 squared. Okay, so in this case, we're going to get our complex number as here is 9 plus, and here is 25. And now you can see that here is going to become root of 34. Okay, so this one becomes our modulus. Okay, so this distance, this means that it's a root of 34. Okay, so this is it. If a complex number can be represented by z like this. Z is equals to, okay, so if you want to write the modulus of z, you're going to say the modulus of z is equals to root 34. Okay, so as easy as that. This is how we find the modulus of a complex number. Okay, so the modulus of a complex number is the distance from the origin to a complex number point. Okay, then to find it, we just say the square root of 3 squared plus 5 squared. Okay, so now we have easily found our modulus of a complex number. Okay, this was that on complex number and our Gantt diagrams. Okay, so we're going to look at the next where we're going to talk about the argument of a complex number, and we're going to talk about another form of a complex number. Okay, so please make sure you subscribe so that you don't miss that. Make sure you stay in touch.